Physics, as a process, exists to describe matter and its motion through space, at least according to Wikipedia. The specific part of physics that we're going to go into detail on today is acceleration. Acceleration can be difficult for people to understand. A lot of the way it works seems counterintuitive to the way we look at the world. However, once your brain is wrapped around it, it's just not that hard to understand. Acceleration is any process at which the velocity of an object changes. Velocity itself can be, vaguely, defined as the change in position divided by the time of travel. Both magnitude and direction are required to define velocity, which makes it a vector quantity. Now that we know this, we can begin to understand acceleration. Acceleration is the change in velocity over a period of time. Acceleration can be calculated by dividing the delta of velocity by the delta of time. In other words, subtracting the initial velocity from the final velocity and dividing it by the final time minus the initial time will get you acceleration. As it is defined by both magnitude and direction, acceleration is also a vector quantity. The thing that puzzles a lot of people is the fact that acceleration is usually associated in people's heads with going fast. This is partially true, but acceleration is tied completely to a change in velocity. Something that goes from 0 to 50 has massive acceleration, while something driving at a constant 100 has no acceleration. Acceleration also has nothing to do with the direction something's traveling in. If something accelerates backwards, while it may have negative velocity, it will have positive acceleration so long as it continues going that way. In the same way, something can have positive velocity and negative acceleration if it is slowing down. So now we have an understanding, at least fundamentally, of how to figure out velocity over a period of time. But what if I told you there was another type of acceleration, one the government doesn't want you to know about? If they find out I'm telling you this, my goose is cooked, but the truth needs to get out. This other type of acceleration is called instantaneous acceleration. Instantaneous acceleration takes place over what is called an infinitesimal time period. Infinitesimal essentially means something that is infinitely small. No matter how small a duration of time you think of, an infinitesimal period is infinitely smaller. It has no duration or extent and can only be defined as a limit. Another thing we should understand is what a derivative is. Essentially, a derivative is the limit of a rate as it approaches zero. For example, instantaneous acceleration is just the derivative of acceleration, which itself is the derivative of velocity in time. And if you want to take it one step further, you could say that velocity is the derivative of time and displacement. Anyways, now that we have all that out of the way, here's how to calculate instantaneous acceleration. What you have to do is pretty easy. All you have to do is divide the derivative of velocity by the derivative of time, and you have your instantaneous acceleration. We have a few nice feathers in our cap. We understand how acceleration works over a period of time, and we even have a basic understanding of instantaneous acceleration, which most people don't even figure out until first year calculus. However, in the real world, things aren't super cut and dried. What if you don't know how much velocity there is? What if you just have to calculate it from the force being applied to the object? Even if you know the forces, how are you going to know how much that force will move the object? That's where a few new concepts come into play. First, we have to talk about net force. Net force is exactly what it sounds like. It's the sum of all the forces acting on the object. For example, if something is being pushed to the right with 200 newtons of force and to the left with 400 newtons of force, we can define the net force as 200 newtons to the left. In other words, if you have two forces acting on an object, the net force is the direction of whatever force is larger. As it has magnitude and direction, net force is a vector quantity. The second is mass, which is the property of a physical body that determines its resistance to acceleration. Something that confuses a lot of people is the difference between mass and weight. Mass has no direction and is a scalar quantity. However, weight is different from mass and is determined as the force exerted on an object by gravity. Since weight has direction and magnitude, it is a vector quantity. Mass and weight may be closely related, but they are two very, very different quantities. Anyways, you're here to learn about acceleration. Using these two quantities, we can figure out the acceleration of an object in the physical world. We can find acceleration by dividing the net force by the mass. Simple, right? Well, it's about to get simpler. Don't know the net force? No problem. Multiply mass and acceleration and you have your net force right there. You can pull off the same trick for two different quantities. Not only have we figured out the nature of normal acceleration, we also know how to calculate infinitesimal acceleration and calculate acceleration from mass and force. Tune in next week, when I'll actually complete and turn in a project in a timely manner.